in that endometrial space under the influence of progesterone after estrogen has acted. Okay. So, attached on either side of the body of the uterus are going to be the fallopian tubes. These are paths, open tubes that pass between the ovary and the lining, or the interior space in the uterus. Falloppio was the guy who discovered these things. They are finger-shaped at the end, and they have, so these are fimbria, are finger-shaped. They're lined with cilia that beat toward the opening in that tube that will lead the eggs into the female tract. The fimbria and the beating cilia are sensitive to the presence of estrogen, estradiol, and they become much more active just before the timing of ovulation. The ovaries are suspended in the middle of the abdominal cavity, or actually near the back wall of the abdominal cavity, by the suspensory ligament. They are vascularized by the uterovarian artery and the uterovarian vein. In many mammals, the surface of the ovary is exposed directly to the fluid space within the abdominal cavity. In rodents and in rabbits, there is a membrane that extends from the surface of the fallopian tube around the ovaries to essentially make that a closed space. That makes their ovulations much more efficient, number one. And number two, you're not going to find any eggs shed into the abdominal space. Occasionally, with the arrangement in most mammals, including humans, you do get eggs that are lost into this abdominal space. Or that can, we'll get to that in a minute. All right. So the uterus is suspended by something called a round ligament. There's a broad ligament, I believe, over here. This is, I believe, a broad ligament as well. So they're suspending that. Okay, a little interesting part. This the vagina and the urethra are both derived from what's called the urogenital plate during development. And interestingly, the lining of the vagina, like the lining of the endometrium, goes through a cyclical growth, development, and shedding that is synchronous with ovarian function. The same is true of the lining of the urethra. It's estrogen sensitive. So if any of you ladies want to do a simple experiment to find out whether that's true or not, just collect your urine or a sample of your urine across the days of your cycle. And let the cells settle to the bottom, because there's going to be a lot of cellular debris in your urine. Okay? Let it settle to the bottom of a tube and measure the height of that column of cells. Just record it. You can dump the tube, rinse the tube, use it the next day. Okay? But if you do that, you're going to find that the volume of cellular debris increases with the days of your cycle and reaches a peak around mid-cycle. Okay. So, Yes. Pardon? You don't have to tell me. You don't have to report the results.
Extra credit.
You don't have to report the results. It's just a funsy kind of experiment. Okay. In addition to these structures, this of course is the nursery for developing embryos, and we'll get into fertilization pretty quickly here. Other structures that the female has, she has an erectile organ called the clitoris, which is an analog of the male penis. It can be androgenized during development and enlarged as a result. So that's forward, in case guys take note of where it is. Forward of the passage, of the urinary passage. The labia minora on the inner side and the outer side develop from the same embryonic structures that the scrotum does. Okay. So we'll get into the development of these a bit later. They obviously kind of enclose and protect the female structures. Okay, I think that's all I need to talk about here. We've seen this before, and this I just wanted to show you with regard to inhibin production in the female. This is the inhibin B in black. This is a profile of inhibin B production. Looks a lot like estrogen production in the ovary. It's being produced by granulosa cells, largely in the first half of the reproductive cycle. Notice that inhibin A starts to go up just after ovulation, and it rises to a peak essentially a week before the menstrual period would ensue over here. This is being produced by the corpora luteum. So you're switching from granulosa cells producing inhibin to corpora lutea producing a slightly different inhibin. If this individual were to get pregnant, inhibin B would go flat, much like the production of progesterone does. And that's because they're both coming from corpora lutea. The little chemistry on the inhibin is just showing you that it's coming from three different genes. You're getting formation of hybrid structures from these, from the alpha subunit and the beta B or beta A forms to form two different forms of inhibin. Okay.
And what should we know from that side is the role of inhibin?
Just the slide, wait a second, previous. I'm mainly focusing on this part, that the form of inhibin shifts from the B form from granulosa cells, which is like the Sertoli cells producing B inhibin, and it shifts over to the A form of inhibin from the corpus luteum. Steroidogenesis we've shown before. Forget this part of it and this part of it. You're going all the way over to androgen production and then to form the estrogens. And there's coordination and functions between the granulosa cells and the thecal cells to form that estrogen. Maturation, skip that one. Okay. And then we're over to egg production in the female. I talked a little bit about this before when we talked about meiosis. that it's different than the simple form that occurs in the male. In the female, the oogonia, the germ stem cells, are going to continue to mitose until a bit before birth. Once you get to birth, in most mammals, a few exceptions, the oogonia, the primordial germ stem cells, the oogonia, cease mitosis. And they're halted in the prophase of meiosis 1, at the stage, just after the stage of DNA replication and crossing over. Those cells stay in that state until they commit to the other state, to completion of meiosis later in development. Now, that commitment can take 40 years. What do you think can happen to those oocytes in 40 years? They might deteriorate, but even if they don't, what's happened in 40 years? Yeah?
Could be like exposed to a bunch of different.
Okay. They're exposed minimally to ambient radiation. And there is radiation here. There's radiation everywhere. Okay? So, radiation. What about anything else? Chemicals. So, things that can potentially be mutagenic. Okay? That can cause changes in DNA. That can affect the outcome of subsequent cell divisions. So those cells are, is there any real mystery in why in later years you get an increase in the number of mutations that show up in offspring of maternal origin? Lesser in the case of paternal origin. Okay. So there's fewer of those mutations that have been readily traced to male aging, and in large part because male stem cells are renewing continually, and they're never stalled in the prophase of meiosis 1, whereas the oocytes are. What time have we got?
Or overtime.
We're over time? Okay. We'll finish this up next time and get into pregnancy.